Basically, what this says is we have a unit circle, okay? Suppose that y equals f of t is a function that tracks the x coordinate. Basically, as we go around this circle, okay? Wait, hold on. So as we go around this circle, isn't this point right here? Okay, so here's 1, 0, right? So it says it's tracking the x coordinate of a point. So this is right now at 1, 0 around the unit circle counterclockwise. So which way is counterclockwise? It's this way, isn't it?
Yes.
Yeah.
Around the unit circle, counterclockwise, starting at 1, 0. That's in the positive direction. Okay? So when it's at 0, when this angle, they're calling the angle T. Okay? When it's at 0, the x value on the unit circle is
1.
perfect. This is all it's saying. And then it's going to pi over 6 in the counterclockwise direction. What's that point?
Is it the square root of 3 over 2?
Yes.
Okay.
3 over 2 comma 1/2. So the x value is the square root of 3 over 2. And so on. All this is different points on the unit circle that you should know. And if you don't, when I say should, what do I mean by that? It would be nice if you knew. But I mean, I can't, everything goes pretty quick in this class. So I'm not saying what you should or shouldn't know, I guess. But does everybody know that much?
Yeah, that makes sense.
Mm-hmm.
That's everything here. That's A, okay? So let me erase this and we'll move down to the next problem. This is actually graphing cosine. Have you all watched graphing cosine? So if I were to start over here with a unit circle, you're used to my circles. Okay. And here I'll start off with an XY graph. Now, if I want the sine, well, here I'm at 0 radians, right?
Mm-hmm.
Okay. 0 radians. And the point here is 1 comma 0. So I know that at 0 radians, the sine is equal to 0 because the sine is always the y value of this point.
Yes.
Okay, so I'm going to start off here with 0, 0. So far, so good?
Yes.
Okay, good. Now, of course, we can graph all these points in between, but it's really hard to graph like square root of 3 over 2, square root of 2 over 2, right? I mean,
Yeah.
I don't need to graph all that. I'm just going to go straight up here to pi over 2. And I know here my point is 0, 1. So my sine value again is the 1. So I'm going to go here. I'm going to say this is pi over 2, and this is 1, and I'm going to put a point in. This is the same as the angle. So there's my angle, and here's my sine of x. I'm just going to take that away. That's my sine of my angle. Okay. Now the next point I'm going to do is pi. So here's pi. And at pi, I have negative 1, 0, right?
Mm-hmm.
So what's my sine value?
0.
Perfect. So I'm going to put a point 0. And then I'm going to come down here to 3 pi over 2. And what's my point here?
Negative 1. Negative 1.
What's the x value?
The x value? Oh, 0.
Good. And the y value is negative 1.
Negative 1.
Good. So that means, and the sign is the y. So I'm going to put -1 here, and I'm going to put another, sorry, not there, at 3 pi over 2. I have -1. And let's just call this 2 pi. Sorry, 2 pi. And at 2 pi, I'm back to where I started, aren't I?
Yes.
Good. And that is 0.
Okay, and it makes the curve the continued.
Exactly.
Okay.
Now, there's my sine graph, and it looks nicer than that. And and I can see basically what's happening there. And not only that, this is called one, as you can see, that's one cycle. And then what's going to happen is I'm going to do the same thing again. So it's just going to keep going on forever, right? Because I can keep going around that circle over and over.
Yeah.
And I can go backwards too, which is a negative angle. So it goes in both direction infinitely from negative infinity to positive infinity. Does that
Okay.
make sense?
Yeah. Yeah.
'Cause I
It's
can
starting
go
to
either
click more.
direction. What?
It's starting to click a little better.
Okay, good. So I can go either direction because I'm either going in a positive angle direction or in a negative angle direction. So I can go negative. I mean, this would be negative pi over 2, right? Which
Yeah.
is here. I mean, it goes on forever. If I wanted to do a cosine graph, well, I'm doing the same exact points, only at 0 radians, I'm picking the x value for cosine. Aren't I?
Yes.
Okay. So my x value at 0 radians is 1. What's my x value at pi over 2?
0, 0.
What's my x value at pi?
-1.
What's my x value at 3 pi over 2?
0.
0.
And what's my x value at 2 pi?
1. 1.
Perfect. So now this is what the cosine graph looks like. And again, it goes on in both directions forever. Okay? They look exactly the same, don't they?
Yes.
The
Yeah.
only difference is one is shifted. It's actually shifted pi over 2 from the other. Does everybody understand basic transformations like horizontal, vertical, shifts, compressions, all that stuff? I know that we teach it in college algebra. Did you get taught this in college algebra?
A little bit. I think it touched on.
Okay. Do you agree?
Yes.
Yeah. So the radian is just you like in like a graphing context, the radian is the x value and then the
Yes.
sine
So
or
X
cosine
is
is the
in,
y value.
yes, exactly.
Okay. Okay.
We're basically graphing angles against trig functions, whatever it is.
Okay.
Okay. That's what, and then we get these waves, and these waves are very important. I mean, electricity works like this, right? They have these waves. AC, this is what AC power does. It goes up and down, alternating currents, right? I don't know if you know that, but that's basically what that is. Okay, we're in good shape.
Yes.
All right. Now, let's see what else we need to talk about. So, oh, I know. So the reason I did that is because I wanted to show you that the reason that they're doing that worksheet the way they're doing it is because they're telling you the points, and you don't have to, obviously, I'm telling you, please don't graph all those in between points because you don't need them. I don't want you to have them. It's too hard. I don't know what the square root of 2, square root of 2 is like 1.414, I think. So 0.707 would be half of that. How are you going to graph that? I mean, it's not necessary. You understand what I'm saying? We're not looking,
Yeah.
you're not going to be reading points off of a graph. I just want you to know how to sketch it. Okay.
Okay, yeah.
Okay, now with vertical transformations, okay, vertical transformations, all this is, these are just vertical. Okay, so you guys, I don't know if you remember, let me see if my whiteboard, where's my whiteboard? So that's why they're asking you all these angles. I disapprove. I don't like this worksheet because you don't need to know all those angles for graphing. Now here, this is, they're saying now graph those points, which is what I just showed you.
The only question I had about this would be because we did I was looking at the one for sine. So
Mhm.
would pi over 4 1, that would be the 0.5, right? It's just going up 0.5 and
It's not
then
really 0.5. The pi over
oh,
4, what's the x values for pi over 4?
Square root 2/2 and
Right.
yeah.
That's not 1/2, is it?
no, not exactly. Yeah.
That's the 0.707-ish one that I just said.
Mm-hmm.
You can use your calculator. This is this is what I would expect that you could do for graphing. You could, here, let's do it. I'm gonna put it on here. So let's do sine first. So here's 0, 0. And then at pi over 2, it's gonna be 1. At pi, it's back to 0. At 3 pi over 2, hold on, let me move this out of the way. It's -1. And at 2 pi, it's back to 0. And then let's see if I can make it somewhat. And if you look here at pi over 4, that's kind of close to 0.7-ish, right? It's
Yeah.
0.75, but I mean, not too bad. And at 3 pi over 4, it should be, it's probably closer to 0.7. Okay? And the sine of pi over 3 is 1/2. And we don't have pi over 3 on this, so it doesn't matter. Okay? So this is the graph of the sine. And they're using t, I'll use t, sine of t. Okay? Does it, all this make sense so far? But this
I
is
guess
not
my question
credit.
is
Okay.
on the quiz we're not going to be asked to do 8 points. I guess is what I'm getting at then. Because
No,
like I don't want to like have to be worried about the 8 points. They can get
no,
off
you
like
don't have to do 8 points. One,
okay.
two, three, four, five. Five
Okay.
points. I'll
That's what I was
actually
just
even if I haven't looked at the quiz yet. If you like, I don't know if I said this last time. If you have any question regarding your grades for the quizzes, you think you did it right and you didn't. I mean, I don't grade those. Those are my TA grades, though. I don't think I would ever sleep if I also had to grade your papers. So, if you think that something was not graded right, just let me know. I'll take a look at it. Okay, absolutely. Without question, I'm happy to do it. But
okay.
but if it says 5, I mean, I mean, you can't draw that on this graph. You know what I mean?
Yeah. That's why I was like asking just to like
Yeah,
double check.
no, I don't expect it. No,
Gotcha.
absolutely not. Now, here's the next thing. If you have a vertical transformation, what does that mean? It means like y equals, let's say 4 sine of t. Okay. So tell me anything that you can think of that because you know a lot about that. Tell me something that you know about 4 sine of t.
Does that mean it shifts up 4 units?
Well, think about it. So if you plug in, let's plug in not 0. Let's plug in pi over 2 for t.
Okay.
Okay? So tell me what happens.
Oh, it's y equals 4.
Right. So what is it doing?
It's just the point is just on 4.
It's
So it's
multiplying. This, if I did this instead of this, what is it doing? It's
oh,
adding,
okay, yeah.
right?
Mm-hmm.
different.
Mm-hmm.
Okay, so they're both vertical. Well, I haven't even, I think that's for next week is the shifting right, left, up, down. This is just multiplication. So this section, this sign of this A part or part one, because we're doing it in two parts, right? Is multiplication. That's it. So if I say that's 4, it's a vertical transformation, right?
Mm-hmm.
Because it's not changing anything horizontally, but it is changing the y-axis. And if you would watch my video, all I do is this. Because that's really all that's happening. I don't have to regraph this. Why would I have to regraph this? I can still know what points I have. At 0, it's 0, because 4 times 0 is 0. At pi over 2, it's 1. 4 times 1 is 4. At pi, it's 0. 4 times 0 is still 0. At 3 pi over 2, it's negative 1 times 4 is negative 4. You see, I got all the points right. All I did is change the axis. Why do I have to redraw it?
Oh, true, yeah.
You see what I mean?
Mm-hmm.
Does everybody get that?
Yes.
Okay, nice and easy, right? No?
It's easy. It's just like I'm like trying to like rewire that in my head right now because it was like very easy to the point where I'm like, oh, why didn't I think of that before?
Well, you didn't watch the videos.
Yeah, I know. I
They're
haven't
all in
gotten
the
to it yet.
videos.
Mm-hmm.
I literally do this in the videos and I do it real slow so that, and I even watched that one video. There's still tons of stuff I can cut out of there because I notice that's the stuff I cut that I guess I missed it. I was probably falling asleep while I was doing it. But, I try to cut it and make it so that it makes sense instead of jumping around. So that's how you do a vertical transformation. That's a compress. What is it called? Vertical stretch compress. Okay, that's all I have to do, isn't it?
Yeah.
I mean,
Yeah.
if this was 40, this would be 40. I actually never put these numbers here, by the way. That's why it's easy. I mean, you could still say 40 times 0.5 is 20 if you wanted to, but why? Okay.
Mm-hmm.
All right. Now let's do one more thing while we're here. Let's do a horizontal one. Let's say we have y equals sine of 2x. Now that's a horizontal transformation. Horizontal transformations are inside of functions. Okay. Do you understand the difference? If I do y equals 2 sine x, that's outside the function. Do you understand what that means when I say those words?
Yes.
Does anybody not? Okay, good. So we did this one. This would just change this to 2, right? The 1s to 2. But we haven't done the horizontal. Does anybody remember anything that your teacher said about horizontal transformations that might help us? I know you just touched on it. They should have said something. No?
I can't pull it from my brain right now.
Okay, that's okay. Okay, so what happens? Vertical always seems to do what we expect it to do, right? We multiply by 4, it gets taller. It stretches up to 4, right? We divide by 4, we divide by 4, it compresses. It would be a fourth as tall because it's vertical, right?
Mm-hmm.
Horizontal does the exact opposite of what we expect. Okay, so what would you expect it to do with 2x?
Stretched by 2 points horizontally,
Right, so you'd expect it to go out wider, right?
outward. Mm-hmm. Yeah.
But it doesn't. It compresses. So when I say it does the opposite, I mean it. Why does it do that? Because think about it like this, and you can watch the videos. I really do go into quite a bit of detail. Well, pi would be pi over 2. And I'm going to explain why it does why it compresses. I'm just getting there. This would be 3 pi over 4, right?
Yes.
I divide by 2. And this would be pi. Okay? Agreed?
Agree.
Okay.
Agreed, yeah.
Okay. Now here's what I'm going to do. I think I'm going to use black. So at pi over 4, this is the point. At pi over 2, this is the point. So we still have the same points. It still looks the same. But notice one cycle now is within pi, not within 2 pi. You see that? Before, it took till I got to 2 pi, I had to go all the way around the circle to get back to the beginning, didn't I?
Yeah.
Look, I got back to the beginning just with going pi. So I would actually have a whole other curve in here before I got, it would actually end, it would end here. Okay, so this would be 2 pi.
So it's slower.
It's actually faster
Oh, it's fast.
because look, I got 2 full cycles in 2 pi.
Oh, I'm thinking it's just stretch. Okay, I understand. I
You
understand.
understand?
Yeah.
Because pi is here. I got 1 cycle in pi, so within 2 pi, I get 2 cycles. If this was 3x, I would have 3 full cycles. Each one of those cycles is called a period. Okay? You're
Yeah,
gonna be
that
asked
makes
about period. It makes
Yeah.
sense?
Yeah, it
Yeah.
does.
Okay, perfect. So it's going faster, and the bigger that number is, the faster it's going because I'm getting more and more cycles or periods within that 2 pi.
So
Okay?
you would say for the 2x, it was 2 periods is 2 pi?
It's one, so the period for 2x would be, so there's a formula that is in the video. The new period is equal to the old period. And I say this because divided by B in the video, but I think it's called omega in your book, actually. I think your book calls it omega, and it's not a textbook, but it is called omega. Hold on, this is my way. Okay, so what does that mean? For sine, cosine, and I don't think we're doing secant or cosecant in this class. As far as graphing, the period is always 2 pi because it's a full revolution around the circle. Okay, so I would say my new period is equal to 2 pi and omega. So I have y equals, I'm going to do it a little simpler, even though your book probably is going to do it different. I'm just going to do it. I think this is easier. So we're going to see this is A, and I'm just going to say trig because it's sine, cosine, or whatever, okay? And then we have bx plus c plus d, okay? So there's 4 different possible transformations. There's actually 6, but that just comes in with a negative, okay? So right now, my A is my amplitude. It's how high it goes. So from 0, if I had a 4 there, remember, that would be 4. My amplitude would be 4. Good?
Yeah.
Yeah.
Here, I don't have the pluses, so we're really not worried about those right now. Let me erase them for the moment because we're not going to talk about C or D yet. And that's next week. So we're not actually going to talk about C or D in this quiz at all. But I can see now that I have 2 pi over b. And my b is 2, right?
Mhm.
So my new period, so this equals 2, so my new period is pi. And that's what I see here. Period is 1 cycle. That's the end of 1 cycle. It ends at pi. Did that make sense?
Yeah. So you just divide
Whatever
like
yes,
by two. Okay. Yeah.
whatever's in here.
Yeah. Right. Exactly.
3, then it would be 2 pi over 3 would be my period.
Gotcha. Yeah, that makes sense.
Okay, good. Is there any questions about any of this? Okay, good. So that's horizontal and vertical transformations. Do you guys know how to tell the difference between a horizontal and vertical transformation? How do you know which it is?
Horizontal is the one like we talked about where it's more compressed and going faster, and then the
But,
vertical.
but more than that, just in general.
Oh, okay. Well, outside of that, not really.
Okay, this is important. And I don't know how to teach you this fast enough. Um, so let me think about this for a second. I want to use something besides trig so you can see it. Let's say I have f of x equals 3e to the 2x. Okay? So this is way outside of your comfort zone, hopefully. Well, not hopefully, but I'm pretty sure. Agreed or no? Is this out of your comfort zone?
Agreed.
Okay, good. Not good, but good. If I want to know what is horizontal and what is vertical, I would say, let's say that f of x is equal to e to the x. I'm going to go down to some people call it the parent function. When you learn transformations, did you learn parent function? Base function? I don't know what to call it. Did they call it anything? Because we can see that our base function or our parent function here is e to the x, can't we?
Yeah.
Yes, yes.
Okay, good. Now, here's how you tell. If I have a times f of x, that would equal a times e to the x. Do you agree?
Yes.
Okay. Is this inside or outside of my function? Here's my function. Here's my function.
Outside?
Side.
Outside. It is. You all see it's outside, right? Outside of my
Yeah.
function. Outside of the function is vertical.
Okay.
Okay. Now, if I change this to f of x, let's just say plus a, this would equal e to the x plus a, wouldn't it?
Yeah.
Mm-hmm.
Is this inside or outside of my function?
Inside.
Inside. Inside is horizontal. I wanted to show you on something that wasn't real obvious. And this is not real obvious. A base to a power is not an obvious what's vertical and what's horizontal. So I'm hoping that I made my point about how to tell.
Yes.
Yes, for sure, definitely.
Okay, good. So now if I have f of, let me find a good color. None of these colors are that great on top of that blue. So let's say I have f of x is equal to sine of x, right? Well, if I have a times f of x equals 4 sine x, because that's the one we used, right?
Mm-hmm.
We can tell now that that's a what?
Vertical.
It's a vertical.
Yeah.
It's obvious now, right? Because it's outside
Yeah.
the function. If I said f of x plus b, I think it was, no, sorry, we're not doing pluses, times. So it was bx, then that was our sine of, I said b was 2x. We can see it's inside the function, can't we?
Yes.
Yes.
That makes us understand that that's horizontal.
Uh-huh.
Okay, so that's the basic way to tell. And when we start adding inside and outside the function, it'll change things more. Okay, that'll be
Yeah.
next.
Next week, yeah.
Okay, so I'm gonna erase all this stuff now. Agreed?
Mhm.
Agree.
Okay. I just don't want to erase the past. All right, so that's all that's happening here, and that's the transformations. I'm just trying to remember everything that you need to know. Complete the table below the exact y values. Okay, so this one was x values. So this was cosine. Yeah, so this one's cosine. It's exactly the same, except we're going to graph the sine function. That's why they're asking for the y values, right? What in the world did I just do? Okay. See here it says complete the table below with exact y values of the point corresponding to each angle t. Is it starting to make sense what this is saying?
Yeah.
Mhm,
Okay,
yeah.
good. That's the most important thing, is that you understand what exactly this says. And then you would graph the sine function because we're on the y values. And there's another graph of the y function. And then it says, how is the graph of y cosine t different from the graph of y sine of t? How are the graphs similar? Well, we kind of talked about it. They're shifted. If I say that, let's do it because I don't know what's on the quiz, so we might as well do everything. So this is pi over 2, pi, here 0. Okay, so we have sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, and sine of 2 pi is 0. Now I have the right points in there. So there's my sine. My cosine is going to be a little different because it's going to start at 1. And then it goes to pi over 2 at 0. Pi is -1. And 3 pi over 2 is 0. And 2 pi is back to 1. So this is my cosine graph. Cosine of t, sine of t. Okay. Now, this is shifted. Of course, we haven't learned anything about shifting yet because that's the plus or minus. So I can't really, I don't want to teach you that right now because it's enough what we're going to go over. But you can see that this point right here, point on the cosine graph, and then we're going to say we're going to move it over to here. We've shifted it to the right pi over 2. And if I take that graph and shift it to the right pi over 2, well, I don't know if I can do it. Let's try. Doesn't seem to want to do it for me. What we're going to pretend, we're going to imagine that we're moving this point right here, this point right here, over to this point right here. We're moving it to the right by pi over 2, aren't we?
Yeah.
That's a horizontal shift, but it's a shift right. It's not a multiplication, that's an addition. Actually, it's a subtraction, believe it or not, but that's horizontal. That's for next week. Okay.
Okay. Mhm.
But if I did, it would look exactly the same. Pi over 2 is the same as 90 degrees. So I can say that it's shifted also. If I had this in degrees, it would be shifted to the right 90 degrees, or it's shifted to the right pi over 2. Same exact graph if I do that, isn't it? It says the tip of a one-link robot is located at theta equals 0 at time t equals 0. as shown in this figure. It takes 4 seconds for the robot to move from 0 to 2 pi. So that's going to be important, okay? And we have L equals 8 inches. And we want to plot the X and Y components as a function of time. Amplitude, frequency, period, phase shift, and time shift. Okay, so let's first talk about what all the pieces are, and then we will graph it, or we could do it the other way. It doesn't really matter. But let's just kind of write down what everything is. So we have amplitude. And amplitude is going to be that 8 inches, which is the length of that arm, right? And then we have, okay, so that's amplitude. Frequency, let's wait for frequency because we can find the period. So the period is going to be so it's going from 0 to 2 pi. So that's so we want to find our new period, right? So it takes 4 seconds for the robot arm to move that far, right? So that means it's going to be over omega. We're going to use omega because now we're talking about things from our book. And we know the new period, right? The new period is 4 because it's taken 4 seconds. And we're plotting this as t. So the period, the new period, is going to equal 4, which tells me what, so we found omega, so we found the period. The frequency is going to be 1 over p, which is equal to 1/4. Okay. The phase angle, the phase angle is the shift. So if we're shifting it right or left, then we have a phase angle that is not 0. But here, the phase angle would be considered 0 because there's no horizontal shift. And the time shift, so the time shift is going to equal, I believe this is a sine functions because it says at theta equals 0, is located at 0 at time 0. So at time 0, everything's 0. So that means we have a sine graph. Sine. Our amplitude is 8. That goes at the beginning. Then we have omega t plus theta. Okay, well, theta is starting at 0. So that makes this 8 sine of omega t So our time shift is always our theta over omega, okay? And since theta is 0, our time shift is 0, okay? So we found all of these things. Now, basically, the last thing we want to do is graph it. So, we didn't find B. We didn't find omega, I'm sorry. But we do know, let me do that. So we know that P nu is equal to 2 pi over omega. And we know P nu equals 4. So 4 is equal to 2 pi over omega, which means omega is equal to 2 pi over 4, which is equal to pi over 2. So now my function is pi over 2t. Okay, now I think we got everything. Function of time, yes. So now we're going to graph it. And I know that, let's see, do I want to graph it that way? I think we could do this easily. Since we know one period is 4, we can just say this is 1, 2, 3, 4. We know it's going to 8 and down to -8. And we know it's a sine, so that means it's starting at 0. At the first, this would normally be pi over 4. So this is our first value, sine of pi, I'm sorry, pi over 2. This would be pi over 2. At pi over 2, our sine is 1, so we go here to 8. This would be pi over, this would just be pi. So this is 0. Actually, I probably should show you how that all works. So let me do that before I, so this is pi over 2. This is pi. This is 3 pi over 2. And this would be 2 pi. We were told that our period is 4 seconds. So after I have that, then I found what omega is. So omega is pi over 2, which means that I would have had to divide each one of these by pi over 2. Divide by pi over 2 and divide by pi over 2. So there's my 1. This is 2. This is 3. And this is 4. Pi's cancel with pi's. 2 cancels with 2. Pi cancels with pi. This becomes times 2 here, and so on. I think you guys can do the algebra. Yes. Okay, now I think I've explained what I need to, and then let's just draw a graph in. So we go up there, go down to here, down to here, and up to here. And that is one period. 2 pi. If L equals 8, that's our amplitude. Plot the X and Y components as a function of time. And then we found our amplitude, our frequency, our period, our phase angle, and our time shift. So I think we've completed problem number 1. All this says is that frequency is the reciprocal of the period, because they're calling the period T. So if
Oh, okay.
okay, that's all it is.
Yeah, I think it's the symbols that weren't translating well. 'Cause
Yes,
it kind of threw me off.
yes. So that's why I'm looking to see what it is how I can relate back to the book here. So omega is what I called B. Okay?
Mhm.
And if the period, I'm going to call it P for period, and then I'm going to say that's the same as T for I don't know what. And we're going to say the period of a normal sine or cosine function is 2 pi. Okay?
Mhm.
Okay. Now, omega is equal to my B. Okay? So
Mhm.
if I say the new period is equal, and I'm not going to say the old period because we're just going to say 2 pi over I believe this is omega, omega. Yeah, so that's equal to, so this gives me my new period. So then if I take this and I do a little bit of algebra, I would say that F, I would say that the frequency is equal to, well, I'll just do this, omega over 2 pi. So 1 over the frequency is equal to 2 pi over omega. Do you agree with both of those statements?
Uh-huh. Yeah.
Okay. Now, 2 pi over omega is the same as my new period.
The period. Okay.
So we can see that they're just reciprocals.
Oh, so it's like that equals that, which equals that.
Yeah. So if I want to
Okay.
know if my period is equal, so if my new period, let's say, is equal to pi, then my frequency is equal to 1 over pi.
1 over pi.
That's all. That's all this says.
Oh, you just made it so much easier to understand than the book.
Yeah, no,